Okay, so I don't know why the video keeps stopping, but we're just gonna keep it moving. So here we're gonna find the slope of a curve at x equals a. And so since they don't give us x, then again, when they don't give you the point, you're finding the slope equation of the curve. And here's it says find the slope of a curve at x equals a, and the function is f of x equals 1 over x. So we're going to use the difference quotient, and that is the limit as h approaches 0, which is what most of you forgot when we did our entrance ticket. But that's very important because you're going to have to plug that in at some point into this formula. So f of the limit as h approaches a of f of a plus h minus f of a all over h. And so here's our function. So everywhere I see an x, I'm going to put a plus h. And then everywhere I see a x, I'm going to put a. So that's what this means. So we practiced this in the first few problems of the lesson. So when we had f of 3, so then everywhere there's an x, I would have put a 3. But since this says f of a plus h, everywhere I have an x, I'm going to put a plus h. And since this says a, f of a, so everywhere I have an x, I'm going to put a. So that's how you look at this. So you want the limit as h approaches 0 of 1 over a plus h minus 1 over a all over h. So again, I plugged in a plus h for x here. Then I plugged in a for x here. And then I finish off the formula by dividing by h. All right, and we have done some of these problems when we're doing limits, when we're factoring limits. So you should be comfortable with this. You want each of your denominator to be your common denominator. So our common denominator would have to be a plus h and h. So everything would get a times a plus h. This gets a times a plus h. And then this gets a times a plus h. And then everything that's the same, you make a 1. And then multiply what's left. A times 1 is left. So we have the limit as h approaches 0 of a times 1, which is a. And then this a is the same as that a. So you make your 1. And then you multiply 1 times a plus h. Being careful that this 1 is negative because of the minus sign in the formula. So you distribute this whole negative 1. So this is negative 1 times a, which is negative a, and then negative 1 times h, which is negative h, all over h. And like we said when we were factoring limits, something should cancel. If nothing cancels, then you did something wrong. So a minus a cancels, and we get the limit as h approaches 0 of negative h over h. And negative h over h. I'm sorry, over, I left all this out, over a times a plus h. And then this is a times a plus h. Forgot all of that. Try not to forget any of that. So then what happens here? That makes a 1. And then we get the limit as h approaches 0. It looks like nothing's there, but that's a -1 all over a times a plus h. And so this is your slope equation because you don't have x, or in this case, a, to plug anything in. The only thing we could have plugged in is this h, which we could still do because now it won't be undefined. So this would be a times a plus 0, which is -1 over a squared. So this is our slope equation. This is the equation we would use if we were given a point on this curve, If we was given a point on this curve, this is the equation we would use to find the slope. Okay, now let's do a problem where we are actually given a point to find the slope and see how that comes out differently. So if we are given a point to find the slope, let's look at example 3 on page 89. They want us to use y equals x squared at point P of 2 and 4. And they want us to take it a little further, but I'm going to take you step by step. And you're going to see how this is very similar to writing equations in Algebra 1. All right, so we write our difference quotient. So it's the limit as h approaches 0 of f of a plus h minus f of a all over h. So in our previous example, x equaled a. But in this example, here's our x. That's y. So here's our x equals 2. So instead of plugging a plus h into our function, we can actually plug in what x actually equals for a. Now if that's confusing, you can put, in the last problem it said x equals a. That should help you here because here's your x and that needs to equal a. Hopefully that makes sense. So instead of putting a plus h squared here, I'm actually going to put the limit as, the limit as h approaches 0 of 2 plus h squared. See, if I didn't know what x was and it said x equals a, I would have put a plus h squared. But now I know what a is. A is x. You plug that in. So now that you know what x is, you're not going to get a slope equation like we did in the previous example. You're actually going to get a number for the slope. All right, minus f of 2 all over h. Okay, hopefully this isn't confusing, but again, you can contact me. All right, so then we have to multiply this out, and hopefully you remember foiling Or if you don't like foiling, you can use the rectangle method. You can distribute twice, but you have to write this out. You have to multiply this out. This does not equal 4 plus h squared. This is the limit as h approaches 0 of 4 plus 4h plus h squared. Now, if you don't know how I got that, off to the side somewhere, you're going to have to write it out. 2 plus h times 2 plus h. And go ahead and distribute. All right. And then you have to do f of 2. So f of 2, you plug 2 here and get 2 to the second power, which is 4. So we follow the formula and put minus 4. And hopefully that's not confusing. I just plugged in f of 2. 2 to the second power is 4. All over h. And again, when you get to this point, something should cancel. So here, the 4's cancel. And we get the limit as h approaches 0 of 4h plus h squared over h. And then we cannot plug in h being 0 because it would be undefined. So again, you're working all this down like we did when we was doing factoring limits. You're going to work all this down so that you can plug in h into the denominator where it does not equal 0. So this has an h, this has 2 h's, this has 1 h. So you can take out an h. You can take out an h. So we have the limit as h approaches 0, 4h over h plus h squared over h. So this would be the limit as h approaches 0 of 4 plus h. Now we can plug in the limit of 4 plus 0. And so we did all that work so that we can get a slope of 4. And now that we got a number, an actual number for our slope, we can find our tangent equation. Tangent equation again is just slope-intercept using a parallel slope. So our slope is 4. Our parallel slope would be 4. Parallel meaning the same thing. So our tangent line, when m equals 4 at point 2 and 4, it's just point slope formula. So now they're tying in, everything from algebra 1. They're just changing the name and you got to know what it means. Tangent means what is the slope at a given point. Our given point is 2 and 4. Our slope is 4 and they want a line. So we need to use this point and this slope. This is our tangent slope. So we need to use this point and this slope to create a tangent line. So I gotta scratch up. Y minus y1 equals m times x minus x1. Because I got a point and a slope, right? Point slope. So y minus 4 equals 4 times x minus 2. Y minus 4 equals 4x minus 8. Add 4 to both sides. Y equals 4x minus 4. So, what this is saying, I don't know if I could pull it up on my calculator. Let's see. Maybe it'll show it. Maybe. So, what this is saying is, hopefully you can see it. I hope you can see it. Okay. Well, I can't zoom in. But, hopefully you can see it. But what this is saying is, if I graph x squared, so that's our curve, because that's a parabola. And then I graph y equals 4x minus 4. And then I graph them in the same coordinate plane. So here's our parabola, x squared. And then here is our 4x minus 4. And the point where they meet, if I trace it, the point where they meet is at 2 and 4, because that's the point I use with the slope I found. So that is the average rate of change, or the slope, at this particular point. Because I don't know who did it in math, but somebody said, well, it's not fair. We can't find the slope of a curve. It's always changing. So let's pinpoint it. Let's find it at one point and figure it out from there. And they did. Okay. And then the normal, so this is called, again, this is called the tangent line. And the tangent line is parallel. This is called the tangent line. The tangent line is parallel slope. So after you use the difference quotient to get the slope, you don't change anything. Use the same slope with the same point and find the slope-intercept form. But they just changed the name. It's called tangent line. And then if they ask for the normal, so let's say they ask for the normal line. The normal line would be the perpendicular. So again, they just changed the name. So parallel is called tangent in calculus, and perpendicular the perpendicular line, the perpendicular slope is called the normal line. So it's the perpendicular slope when writing an equation. Okay, so again, I'm on page 91, problem 5. And they want you to write